starts lesson 6.6, part B. So how do we write an equation that's in standard form and put it in vertex form? Well, that's where completing the square comes into play. Yes, a heavy sigh from everyone, but it does have a very useful purpose. So we're going to take a look at this, and we're going to remember that we now have y equals, and then we have the quadratic on the right side. So we're going to approach this the same way we did yesterday, but with a little bit different flavor, because we're going to add something new to it. And I'm going to keep the 4, okay, on the same side. And remember our rule about if we have an equation, we have to maintain balance. So when you complete the square and you add something to one side of the equation, you must add it to the other to maintain balance. Well, there's another way to maintain balance. If we add something to one side, we can also keep it balanced by subtracting the same amount from the same side, knowing that these two things that we add and subtract are canceling each other out, thus keeping the balance. Okay, so with that in mind, we're not going to touch the left side right now. And in doing so, we can go ahead and complete the square. We take our x term, our x coefficient, divide by 2, and square it. That will give us 1. So 1 is the number that will allow us to complete the square. Now keep in mind that we're trying to complete this part. So right now I'm going to go right to the step where we have something squared. Remember, it is completed, so we will have a binomial that is the same for each one, which means we can write it as one binomial squared. So if I were to factor this, I would have x, a plus plus is a plus plus, and a 1, and a 1. This giving us x plus 1 quantity squared. This then gets put together as a plus 3. Now we have it in vertex form. We have a lead coefficient, or A of 1, so we know it opens up. We have a vertex of, okay, this one moved 1 unit to the left, so it's -1. This moved 3 units up. That is our vertex. Again, a perk is that the axis is of symmetry, so we x equals same x value as our vertex. And that is analyzed. And we could graph that, but this is all we're asked to do. Change it to vertex form and then tell us where those things lie. Next one, notice that we have a -2 in front of x squared. Same process, but we have learned already that we cannot complete the square if we do not have a 1 in front of x squared. So we had to, yesterday, divide everything by whatever was in front. Now, again, we're going to take a look at this a little bit differently than yesterday, because we have y equals on the other side and not 0. Now again, we're going to focus on specific pieces, just like our last question. We're going to look at -2x squared minus 4x. Again, this piece is going to shift over. And again, we're going to focus on this part. We're going to take out a -2. We're going to factor out a -2. And then in parentheses, we'll write what we have left. That'll give us x squared plus 2x. Now, here's where we're going to complete the square. We have x squared plus 2x plus whatever it takes to complete. We have our plus 2, and we're going to subtract the appropriate value to keep it balanced. Again, yesterday I would have added it to this side, but I'm going to stay away from that side right now. Because what happens in the past when I've done this, we forget to bring it back over, okay, when we solve for y at the very end. So it's kind of taking away one step and hopefully making it a little bit simpler, but we do have to understand why we are adding an amount and subtracting it, because we want to do both of these to maintain balance. Okay? Now how do we complete the square? Well, we take our x term, divide by 2, square it, and again we get 1. Now here's where we have to be careful, so follow closely. If I put a 1 in here, most would want to put a 1 here. But in this particular case, we can't. Can you tell why? If I put a 1 here, it's in the parentheses. Now, if I were to redistribute that negative 2, what would it become? That is correct. It would become a negative 2. So I'm actually going to put a negative 2 here, because that is what the actual value is in this equation. Again, why am I not putting a 1 there? Because if I were to redistribute this negative 2, it would make that 1 become a negative 2. So I'm going to subtract a negative 2. Now with that said, we now have a trinomial that is a perfect square. And this, notice it's minus a negative 2 on purpose. We're going to subtract whatever's in there. And it's a negative 2, so it becomes plus 2, and we get 4. So now we have a direction. A is negative, so it opens down, which means we have a max. I forgot to write on that last question about it being a min when it opened upward. We have a vertex of negative 1 and positive 4. We have an axis of symmetry of x equals negative 1. Okay, now not an easy thing to jump at. I'm going from a difficult question to an even more difficult question in this problem, but again, it takes practice. So follow your notes and be careful of each step you take, so you know that you're following the rules that we've set. Now, how do we write this? Well, this one is actually pretty straightforward. That's the good news, right? We have y equals a x minus h quantity squared plus k. And I believe due to time, I'm going to stop there, and I will finish this question in part C.